Yes. So again, hi everyone. I'm Björn. I work for a company called Xing. I suppose most of you know Xing, the green German version of LinkedIn. I work there in the API team as a team lead engineering there, and I'm responsible for the GraphQL project right now, which has been running since the start of the year, basically. Now that you know who I am, it would be lovely to give you a little bit, give me a little bit more impression who you are. So how many of you are front-end people? Okay, and the rest is back-end? Nods, yes. Okay. How many of you have GraphQL actually in production somehow? Okay, it's more than usual. And how many are planning to put it into production or have some ongoing projects? Okay. Why are you laughing?
Because we have different opinions.
Oh, that's interesting. Let's see how I can contribute to them. Our tour for today is first I would like to give you a little bit of context why Xing is actually doing that and what we want to achieve with this project. Because there are some challenges we would like to address, and we think GraphQL for itself is a good fit. They might not necessarily be your challenges, just to make that clear. Then I would go over, and this is where we spent the majority of the talk actually, is our year, basically, what we ran into, how we set up the whole project, how we're rolling out this whole thing, what we bumped into, what went wrong, what went awesomely well, to basically where we are today. So this is soon. So this is already fully in production, basically, but it's not 100% visible to the end user. So we have the system in production since, I guess, June. But a lot of with traffic generation, and we're slowly rolling it out now with our first product. And I'll tell you a little bit more about that. And last but not least, I'll finish a little bit with our take on GraphQL. What's pretty awesome. What's sort of we don't really know now. It's workable, but it could be improved, and also the areas that we don't like so much about it, or specifically some of our front-enders don't like so much about it. So, told you what Xing is. So context matters. Xing is a fairly big company nowadays, so we're roughly 1,000 people and 250 engineers working concurrently on the platform. I show you a next slide that gives an impression of the size of Xing as a whole, as an application platform. But out of that, basically, it resides in different problems than you would normally have in a simpler setup with less distribution, which is also the second point. We're a distributed platform, and we're fairly old. Right? Xing is existing since 2003, basically, and the platform itself has gone through multiple iterations and multiple technologies along the way. We're running on top of multiple technologies, either through buy-ins or some strategic decisions, which also makes some of the things a little bit harder than usual. Right? Last but not least, GraphQL is also new for us, right? So we don't expect to do everything right in the first place, and we'll make mistakes, but we try to correct them as we go, and try to learn as possible, and that also influences our setup basically along the way. Talking about platform growth. So when I joined Xing in 2012, it was 6 distributed applications. Nowadays it's 140, with roughly 50 teams working on the platform. And all of those funny dots there are basically some sorts of API that are exposed, and this is roughly how it looks from above, right? So obviously it's not so super straightforward from the front-end perspective. If you have a large array of services to work with, and the documentation sometimes is not, I mean, who documents stuff? Sometimes we do, sometimes we forget about it, sometimes it's sort of at an intermediate state. So coming from that point, we identified already several years ago, basically, that it's sort of challenging to get data from the platform as a front end. I mean, in the end, the front end has to bring all of this together to some cohesive things, to a cohesive product. And how to get, especially if you run, we don't like the term so much, but if you have something like a microservice-like setup, how do you get data efficient together, right? And how do you deal with all the intermediate problems that arise from that? Last but not least, how do you deal with darn changes, right? Because you don't want to break your old versions, especially for mobile apps, but you want to evolve your products. And this might sometimes involve adding stuff to your APIs in an incompatible way. Right now, this is what we do product-wise. So we build basically for all platforms simultaneously. Xing is organized sort of in verticals, and all teams basically are building for iOS, for Android, React as well, for all screen sizes simultaneously. And this is sort of also where in the past there were a lot of things happening on the front ends to integrate things together, where we naturally think, okay, we're pushing some of those kind of things down to a integration point. And this is actually where we are. We have a lot of interest in something like an integrator layer or integration engine whatsoever. We did that manually for quite a while. I mean, I'm just jumping over our options here. So this BFF pattern, I think most of you probably know it, right? So special kind of view-centric endpoints that aggregates things together. We did that. We had some organizational challenges with that, especially when the teams that build services are different than the teams that aggregate them together, and the APIs are not straightforward in terms of modeling sometimes, which happens. So sometimes we were exposing things in a slightly incorrect fashion with slight different variations on different devices. Also, we had sort of coordination problems in this setup. Because at that time, when we did that, mobile, for instance, was a fairly appendix to the platform, and most of the company was actually doing web development. Nowadays, half of the traffic of Xing is basically mobile traffic, and everything we build is basically at the same time. It should be available at the same time for mobile. That's why already several years ago we switched to something, for the lack of better term here, we call domain team APIs, which is in a nutshell the idea that a team is responsible for all its representations, including basically the API, including obviously the consuming of those kind of things from a mobile perspective, and runs those kind of things end to end, and is also enabled to do those kind of things end to end, which removes a lot of coordination problems from the whole system, but comes with a slightly messy side effect, which is that if you push those kind of things down, obviously the dependencies around the app, the dependency situation becomes more complex, because for every use case now a specific app needs to deal with all the dependencies that are necessary for that particular use case. And what we want to have with GraphQL is a sort of a best of those kind of things. Yeah, we want to have good performance. We want to have some means to contribute fairly easy to the whole thing. It should be owned mostly by the respective team. The people who know the domain should be able to build out every representation about that. But we don't want, for instance, to build individually for web and mobile anymore. This is sort of a relict out of the old ages. We want to build at the same time, in the same form, feature-wise, for all platforms. And along the way, it would be lovely to have higher consistency, right? Obviously, once you scale out and do more things in parallel, there's always the danger that you leave some things. And we want to have sort of a stronger architectural picture, which we clearly didn't have in the middle. And what we actually ended up having in production is sort of this. It's a very, very high-level picture, but sort of services, APIs mostly, and a proxy in front of that, who exposes its schema for multiple channels. That's how we're calling it. Mobile is one channel for that, which includes OAuth for authentication, and single sign-on web is a different channel with different capabilities, but they're basically using the same kind of API and the same kind of schema underneath. So, the road so far. How did we start building that? At Xing, there's an internal process called ACE, which is actually quite handy to figure out, okay, how we're building things. It's about aligning stakeholders and figuring out whether this makes sense sort of strategically. And out of that, we did something called pre-mortem. That's just a fancy name for everything that might kill us, basically a risk analysis. This is how it more or less looked like. And out of that, we basically generated a checklist, an implementation checklist, and did a extensive set of prototypes, because it wasn't really clear in which technology we would build this thing from the start. As I said, Xing is using multiple technologies, so most of the company is familiar with Ruby on Rails. Doesn't really work well if you want to have a proxy with a lot that should have probably integrated in a lot of APIs concurrently, right? Xing has some experience with Erlang and Elixir. In fact, with 2 production apps in Elixir. Sounds better. That's also something we tested. We're doing and investing lately heavily in React. So even if we don't have a backend Node.js app in production, it sounded like an alternative, which we would at least wanted to look at. And last but not least, the whole data science part, recommendations part of the platform is all completely written in Scala. So that was the other thing which we have already in the platform we wanted to evaluate. From a timeline, basically, we wanted to get that done until March. So basically, figure out in which technology we wanted to implement that, then select the target stack, and also identify a lighthouse project, because we thought it doesn't make really sense to build that out theoretically and then figure out a client for that, because most of the problems reside when you actually start out building something, a real product. And that's why we convinced people, and luckily that worked, to actually really build something and to accept that this might result in a failure. But we really got also a fairly big project for that started, which is basically the revamp of the profile. So Xing is getting a new profile section, and this is completely done for all platforms with this kind of technology. But we had to start it somehow, and we basically had no software. And there's a consumer team who wants to build a profile and wants to figure out what to build. That's why we separated a little bit into 2 parts, so to speak. So they were running with an intermediate GraphQL Ruby-based implementation so that they could learn schema development and what it means in terms of integration from a client side and in terms of modeling a schema in GraphQL. I mean, that's different to classic REST APIs, right? And we spent our time here. We implemented actually a prototype 4 times. The first one was just immediately a throwaway because it was just to learn the concept. The second one was our preferred solution, because we were pretty much fans of Elixir, but unfortunately absent the GraphQL framework that is available in Elixir just wasn't up to what we needed at that particular point, and it was also fairly opinionated in how to do things. And we're specifically searching for something that we could pull apart, where each individual part was quite fairly good documented, and there was a clear strategy on how to do things. We looked at Node. Personally, this kind of proxy situation, I would have, and I'm not talking badly about Node, but I would have a bad feeling implementing that kind of stuff in Node, because we're also expecting sort of a lot of refactoring along the way. Plus, it turned out that actually the reference, that the JavaScript version, especially the GraphQL.js, is actually a reference implementation. So if you look at it feature-wise, it's actually where you get the least in terms of features. Apollo is better nowadays and has a completely different way of doing things, so Apollo Server. But even there, it was not really so clear for us what to pick, how to pull it together, and what the strategy to evolve that. Plus, we didn't have any experience with server-side JavaScript in the company. That's why we ended up, in the end, with Scala and Sangria. Mostly less because of Scala, but more because of Sangria. Because Sangria is just, I mean, for multiple reasons, it's well documented, is highly extensible, is also, if you work with this, fairly easy to comprehend how the APIs look like and how it's put together, and you could pull it apart. So you could execute query parsing independently of the execution engine if you had to, which would be also quite handy if you ever need it. But we didn't have Scala experience. So as I said, it was already used by other teams. Luckily, I mean, we were not completely lost because the majority of the team had already worked in statically typed languages, C# and Java, and 2 of us had worked in even functional languages, Elixir and Haskell. For the rest of the stuff, like how does it feel to operate that, and how do we tune that stuff, we got support we brought in somebody. And then we settled on something which I call the sane Scala. Right? So basically, we did code analysis and automatic code formatting and style generation from the start. We defined basically just one way to write things. In Scala, you can do all sorts of crazy things with the language, but we took the most boring one. And we decidedly were also uncool, right? So we treated Scala more like a better Java version, and not like a poor man's Haskell, right? So especially if you know Scala, implicits is one of those areas. In type classes, we did a long straight curve around those things mostly. Last but not least, something that turned out in retrospect really like a good idea, but wasn't so obvious at the time. We wrote almost every test in the system as sort of an integration test against the GraphQL engine. So this is how it more or less looks like. So basically you have a query, you run it, you get some status code and results back. And those are fairly refactoring stable. That allowed us to basically have a fairly stable code base and do all sorts of changes internally without having to adapt the test code base. And you see here also some other interesting things. This is basically a test for a syntax error. And we added some other things to make it, even if you don't use client-side tools, to make it easier to work with GraphQL. One of those areas is, for instance, documented sort of error classifiers. Right? Usually you don't have an identifier what this kind of error is in GraphQL. We added that. Also, what does that actually mean? We, from the get-go, decided to have really, following the example of Sangria, having really strong documentation and link those kind of two experiences together. And you see that on the next slide. And expose also more information than you would normally have in a GraphQL error. So where the syntax error here happening specifically, which this kind of thing was not possible in Absinthe and Elixir, for instance. That's one of the reasons why we strayed away. We just couldn't figure out a way to tunnel errors appropriately through the GraphQL layer there. This is how our documentation looked like. This is basically a Jekyll blog, and we use GitHub internally. And whenever we add something to the platform, it's extensively documented in the same pull request, also as a preparement to scale that out to the organization, which is also only possible because of this decision. Everything tool-wise is in a mono repo, documentation, tools around that, so that we can sort of change them on the fly, basically in a single consistent pull request. Right? Is the documentation there? Have the tools been adapted? Is the schema dump already there? So one of the things we're also doing is like dumping the schema to a file that it can easily be imported by other tools, which really helped us to iterate and learn from mistakes in a sort of sane way, because we didn't need to reshuffle a lot of the setup around. We also have a sort of simplified version of the Sangria DSL. And that's what we started out with. And here it becomes interesting, because we planned decidedly that writing Scala code for the proxy is just an intermediate step. And in the long run, we wanted to have a model where you don't actually need to have know Scala and be knowledgeable in Scala in order to contribute to the whole thing. But you want to check the infrastructure, roll it out, and it seemed to us like the whole productivity thing seemed to be like a step afterwards, not the initial step. So that's why we started out writing the whole schema in Scala, basically simplified, because it's basically just a JSON proxy, right? So the resolvers either do a REST call or they pull out something out of a JSON document. This is why most of the typing is already fairly obvious, and we slimmed it a little bit down. Also, we made it self-contained, so that we can experiment with the structure, how we basically organize the schema internally, so that we can easily move things around. That one I already said. And we would have a special definition for REST fields, which automatically would become optional. Right? Because one of the things we were training our front ends from the start is basically, and this is, I think, quite a difference, at least for us in the company, that it's not binary anymore in terms of request response. And the model, what we know from REST, basically, either succeeded or not. Now you get partial failures, and things might not be there, because you're aggregating of different sources, and I mean, a large platform is potentially messy. There might be network splits, there might be timeouts, those kind of things. So you either hide that from the clients, and we specifically decided not to do that and surface that. So all the things that might fail is explicitly modeled as optional in the schema. Another thing we do is SelectionSet Forwarding. So a selection set is basically the term for the fields on a GraphQL type that you're requesting. And since we're a proxy and we already had this internally, is that all of our APIs, our REST APIs, supported a fields parameter, where you could say, okay, I want to have this field, comma, this field, comma, this field, and you would just got that back, which obviously is a bandwidth optimization, right? You are explicit in what you need, which helps you then later figuring out, okay, what all the parties involved are needing from you, which is nice when you want to deprecate things. And obviously it helps to reduce the amount of data that's passed around in your data center. Another thing, internal apps mostly, as I said, use Rails, and that involves, unfortunately, snake case. Front-end people hate snake case. That's one thing I learned. And that's why we're also doing automatic case conversions. Where we need, basically, we convert to camel case on the fly and do those kind of things together, basically for all the APIs we integrate into the platform. Last but not least, as I said, we're multi-channel. This is sort of a heritage from our public API. It's not immediately obvious. So we treat mobile APIs slightly different than web APIs. The mobile infrastructure was initially based on Xing's public API, which doesn't exist anymore, but there was and still is something in Xing's public API that was intended to basically prevent crawling the API, like crawling all jobs, crawling all users, those kind of things. All IDs in the public API have a signature appended, which is basically specific to the OAuth consumer key, which kind of looks like that. And this is basically where all our mobile apps are built around. This is very hard to get rid of. We don't like it nowadays so much, but this means that we have to expose IDs completely different to the mobile world. Luckily, GraphQL is also contributing one side to that, and Oleg contributed the other missing part. In the schema, you already have a notion, okay, that this is going to be an ID, right? And Sangria also has this concept of middlewares. So you could basically, which wasn't possible at the time, but when we talked to Oleg, then later became possible. You could basically in a middleware do those kind of conversions if you need that. So the schema doesn't know anything about this whole mobile world. It's just an ad hoc middleware that is plugged into the whole pipeline for this particular channel, and the rest stays as is, which is pretty cool. And please, again, say big kudos to Oleg for that. He was immensely helpful with this. We were steering there next for security audit, and at the same time wanted to have basic monitoring in place. And that's also one of the things, like getting insights as fast as possible, especially since we didn't know a lot of Scala there. Okay, how is the app behaving? Those kind of things that you don't want to find out when there's really a lot of traffic customer facing on the application and things go wrong. So we built already that at the very early stage, JVM graphs, how memory ensured time and bursts of traffic, how all of that worked, and how the application behaved. And we also integrated it into our standard monitoring tools that we use internally at Xing. This is one of those typical open source projects with one user. This logjam, well, that's not really fair, but I think there are just two handful of users. And we are probably the largest ones. This is more or less the way we monitor internally most of our backend apps. And what I wanted to show you here is basically some of the things. So since there was no product, we wanted to put traffic on the system early, so we generated basically traffic. And the way we did that is basically that we just basically hooked into the platform at a very central place, and for every mobile request that was done to Xing, we generated asynchronously a GraphQL request. All a little bit feature toggled and controlled so that you can ramp it up and down and see how the whole thing behaves. But in a nutshell, that's how we continuously got more and more traffic, even when there wasn't a real product there at that time. At the same time, we figured out, okay, how do we track actually those kind of things? In the old time, you had controllers either, or you had URLs. And roughly in GraphQL, there's there's sort of the optional query or mutation name, so that makes sense. But if you look at mobile as a scenario, then you pretty soon realize that two different versions of an app might have completely different queries under the same name. So that's why we decided to basically have the platform and at least the major and minor version also encoded there, so that we can see a data, for instance, when the query has massively different characteristics from version to version. And I mean, this is sort of limited. We don't do this for all versions that are out there. The stuff that we ignore at some point becomes, we don't care. But for the topmost versions, we track it explicitly like that, so that you can see them side by side. For the web version, we don't do, obviously, version-specific stuff, because it's so easy to roll it out, and most of the time you just have the most recent version on production. If we dig one level deeper, this is how it looks like, and that's how we cramp this into a more request response oriented tool. So what we see here is basically the requests that were done to all the other apps. Here, for instance, you can also see this is a direct link to that particular request, which is also stored there into the platform, so you can jump around from calling system and back to trace something through the whole platform. We're using basically Sangria Slowlog to basically get the query into the log, and also how much each part of the query was executed there. And some other things you see here, for instance, all of our backend systems basically deliver via an HTTP header how long they took to process data. And if you compare how long did I wait for the data, how long did the backend system notify us, how long it took, you know something, okay, when the data is large, something is going on. And what we're seeing here is actually, this is a screenshot of a garbage collection that is running. And it's a request where something was going on in our app. With all of those funny log data we have, we can also generate this kind of information, which also comes handier if you want to look deeper into the system. Like, okay, what is this really doing? I know we are talking to those kind of APIs, but what are those APIs doing under the hood, and what's the whole chain? What we also have, which I didn't show here, which is also automatically derived from the log data, is Graylog2 integration to search over the last days of requests across multiple platforms, which is also quite handy. After we had all of that, basically, and the security audit was passed, which was done externally, we were more or less running in production, but then we decided, okay, now let's figure out, okay, how do we break this whole thing? So the next step was basically to figure out how to make it fast and how to not render it into a state that we have to get up in the middle of the night for support calls. Right? So the ideal state is errors happen, yes, they do, but the system should automatically recover back to the state. And what we did is basically we used Gatlin extensively to just hammer the system until it was laying on its back and just supervise it what happened in the end and how the system recovered and whether it did come back afterwards. And we did another round of this kind of tests with a tool called ToxiProxy from Shopify, which basically did the other side. So to the internals, what happens if for some reasons some things in the internal APIs get dramatically slow, or connections are thrown away, or dropped somewhere in between? How does the proxy and how does the infrastructure behave in those kind of situations? And we profiled, and this is the earliest screenshot I could find, which was pretty bad, especially if you look at that one here, you didn't even manage to get 100 requests per second through. This is one from a later point in time, which had already somewhere around 350 requests per second end-to-end against the underlying API, which is also sort of limiting how fast we could go on a single node. I don't have a current up-to-date version, but we are somewhere around 500, 550 something requests per node, which we can handle with multiple integrations, right? So pulling things apart or together from multiple sizes or areas. Making it resilient involves obviously, timeouts, right? Making sure that you cut basically the connection after a certain time if it is too slow. And don't wait too long. Unfortunately, though, for us, that surfaced another problem, and we were just getting started at that time. We were heavily using both parts of akka HTTP, so it comes in two flavors. There's either a server-side, basically server-side web framework and a client layer. And the server part works fairly good for us, but the client one not so much. Is anyone of you using akka HTTP on the client side? Ah, good. So I think it's a conceptual problem, because that thing is sort of modeled as a stream, and if you look at the docs from this kind of thing, it says to you, okay, on errors, be super careful to consume basically the stream, otherwise you will run out of resources, and when you run out of resources, basically the whole pool, the connection pool, is dead and it doesn't recover anymore. The bad side of it, we could simulate it in the app, in multiple apps. So it's not something that is specific to Sangria. It also in a normal Play app that it was doing requests with akka HTTP, but we weren't able to extract it into a unit test for a bug report. We had a extensive bug report, but it was like more from the maintainer side, like, okay, is it really happening? We don't know. I don't know. It may be not so important. So since we didn't want to wait, we decided to go another route and ripped this particular piece completely out of our code base and replaced the client-side layer with Twitter's Vinegar, which turned out to be quite a good decision. Vinegar is also like a Twitter's junk drawer. There's lots of tools in there. There's a server-side web framework, and a client abstraction. Both are sort of follow a similar pattern. It's basically your server as a function, as a composable function. So it's a fairly easy, simple request reply interface, basically, which is wrapped around the idea of futures in a nutshell. So something that might complete somewhere in the future. Vinegar worked, but we had to adjust it. And some of the things that came with Vinegar which we still wanted to have anyway, which were on our roadmap, were circuit breakers. So like, what happens basically when one part of your platform is massively in problems, right, and throwing errors? Do you want to still hammer it, or do you want to, if you know, okay, it's throwing errors, do you want to stop calling it for a time being and just saying, okay, we have a problem here, this is not working, and then at a later point try again and see whether you can still call this thing again. This is known as the circuit breaker pattern, and used also in multiple larger systems around the world. If you know Hysterix from Netflix, by the way, this is also exactly this. Unfortunately, though, this in terms of code base, this works on a client level. We had multiple things we wanted to separate from each other. So what we ended up doing there is basically that we have basically something like an internal router to multiple clients there, so that we can isolate parts of the platform into different circuit breakers at the same time with different characteristics. What's also cool about the way Finnegal does that is that they, by default, support jittered exponential backoff. So basically, this the whole question: when are you retrying? You try, and exponential backoff is when you run into an error, then you try a little bit later again. And when you then run into an error, you try even a bit, wait even a bit longer. And this retrying is basically tied together with a random factor, so that not every in a multi-cluster setup, but not every server tries to retry at the same time and is hammering the system that is under fire again. It also comes with automatic retry, configurable retry situation, because, for instance, when we're deploying and we're taking things out of the load balancer and put something into the load balancer, there's sometimes intermediate situations where the load balancer just gives us a service is unavailable status code, and those kind of things, if we retry there, we can usually make it work pretty fast, because most of the deployments are just rolling deployments at Xing anyway. This is basically what we're using in a nutshell. As I said, as a server part, akka HTTP. We started out with a different JSON implementation. We started out with JSON4S. Never used JSON4S, especially not for the case we did. I mean, it might work in other cases, but it's one of those kind of things where we didn't put a lot of thought in, and we just took the one that was recommended to it. Yeah, it should work. But JSON4S has JSON objects implemented in terms of lists. So, which becomes interesting when you want to do key lookups for large documents, right? And basically what our GraphQL server does is selectively pulling things out of JSON documents, right? What can go wrong? Well, that's why we switched to play JSON, not because we think that play JSON is the best in that particular scenario, but it was mostly compatible to the way JSON4S works. We also evaluated Circe there, and if we were to start from scratch, we would probably have taken Circe. But the change was much larger compared to play JSON, so it just wasn't worth the effort. Sangria, as I said, is awesome. It's, I think, the best GraphQL server out there. Finnegal, I also talked about that. And Scala shows to you that we're really uncool. So functional language and dependency injection together in the mix. Why do we have that there? For two reasons. And this is basically just some slides to give you an impression how our app actually looks like. So the server part is super slim. It's just an interface, and it passes over to something which we call kernel, for the lack of a better name, and it's responsible for basically loading and unloading everything that is schema dependent. Because at some point, that's something we already implemented, we wanted to push, at least in the development environment, schema changes directly to the server, and wanted it to automatically pick it up without recompiling Scala code whatsoever. Inside there are multiple GraphQL engines, basically one for each channel. And the GraphQL engine has basically an authenticator, which is different based on the environment you're in and basically the environment you're exposed to. So we make it easier in development environment so that you can start the whole thing locally and connect to something remote or on a VM, on a development VM. And we make it, the more we go towards production, the more, controlled we make it in the end. Obviously the schema is in there, executor is in there. The request context is basically where most of the Finnegal interfaces and HTTP interfaces are there. This is what you talk to in the resolvers in a nutshell, and we have some functions on the request context basically for doing HTTP GET, HTTP PUT whatsoever, and HTTP GET batched. And we have basically something called a middleware provider. Java names are so horrible. What it actually does is basically we selectively pull in middlewares, for instance, also on a per request base. So there are some certain features you can basically, in the development environments, in the staging environments, enable via certain HTTP headers. For instance, tracing, those kind of things, or deprecation warnings, those kind of things would be examples. They're usually implemented using middlewares and are just laying around the engine, and this is not part of the core thing. And then there's query reducer provider, another nice name, which is also just basically all of the checks that that make sure that the query is not too complex and not too deep, preventing basically denial of service scenarios in a nutshell. Those kind of things are, as I said, channel and environment specific. So for instance, this field scrambling stuff, which I talked earlier about, is just a middleware, which is just hooked into one particular case of the whole thing. Slow log, the one we use for our log, for logging and tracing there, is also just a middleware. And as I said, there are stuff which can be enabled by request. So same for the query reducers. We also do something like to surface insights, like automatically export to our metrics database what kind of fields are used on which versions of the mobile device, to allow sort of elaborate product level decisions to figure out, okay, how many people are actually using this field? How many apps are using this field? Right? Is it how large is the impact if we would just remove that field? Can we remove it? Is it used? The last thing which we just finished is the sort of productivity milestone, which involved basically removing the need to write Scala for most of the cases and having a revamped development cycle. Why do we do this? I mean, one of the reasons behind that is basically a scale out question, right? So do you want really to teach 100 people or so who were working with the system Scala? We don't think so. And the other reason is this one, right? Coffee mug, Scala, irony in one picture. I love Scala. I like the language, but this compiler is really something that bugs me enormously, and the workflow it imposes on us. I mean, doing a simple change in our dev environments takes minutes, right? Like changing it, compiling it, or building the Docker image even from it, syncing it to some portion, and that's just not the workflow we want to have. And what we ended up doing, I'm just showing you a video for that, is this. So how many of you guys know IDL or SDL? 1, 2. Okay, the rest, not so much. That's good. So IDL is sort of I think it's a byproduct, because I think they just at the original time they needed something to describe schemas in, which was language agnostic, and that's how this whole format came into being. Initially it was called IDL, and it still is called IDL in our code base. Nowadays everybody is calling it SDL, but we don't want to rename everything, so that's why we're still calling it IDL. In a nutshell, it's a very simple textual format which describes schemas and directives. And it can be extended via something in GraphQL called directives that basically define the execution characteristics of that. Let's look at that. So We can even basically on the fly throw out our schema in our application. This is just really bare knuckle server with just a placeholder field which is not connected to anything. You see the extend query here. Now it becomes interesting. So this is something where we say basically we extend the query type from GraphQL and we add 2 fields here. And we have something interesting here at the right side, which are just basically generated directives, generated from this part here, parameterized together with something that looks like string interpolation, but is actually a compile time expression that we evaluate and shrink as much as possible and make as efficient as possible when we build up the schema. And what this basically does, it basically says, okay, the ID here is used as an input here to this kind of thing, which in turn here is basically a batch query. That part is wrong, ignore that one. But it basically allows doing internally batching and define batching in IDL so that you have multiple occurrences in a query. You see the query now in a sec. That was it. And the whole thing is able to figure out how to batch those kind of things together in a single request. You might have noticed this part here. This is also one of the tools we wrote to just push those kind of changes to a running app, and everything that is sort of schema related is automatically reloaded, which includes metadata and some of the internal caches we have there, and the rest instantaneously works. So coming from something which takes, I don't know, just for compiling a minute or so, and then you put Docker and syncing and all of that stuff on top of that, so multiple minutes, to something that takes 3 seconds. This is what we're aiming for in terms of a development environment for this. Question number 1, is it fast enough? Yes, it is. So basically we benchmark this, and of course this generic part here is slower than when you would normally write it in plain Scala. But the overall net result is that this is sort of only 8% slower than the natively written Scala code. Exactly the same thing, which is for our case definitely something which we accept and we're happy to live with. At the same time, this is already well supported in editors, IDL, Atom, Code, GitHub, whatsoever. We have broad support for that. It's easy to learn. You don't need to teach everyone Scala in order to use that. And if you really need Scala, we've written the app in a way that you can always go back to Scala if you need to do heavy lifting for that. To contribute that, basically all you do is take that file, do a pull request, give us the file, and then it's in the proxy. The final schema. Basically, when we talk about schema, it's actually multiple things, and what I just showed you is the right part of things. When you contribute things, it's ending up here, but there's also sort of some base level Scala stuff in there. So like all of our definition of common types, all of our custom Scalas, those kind of things, those are developed in Scala and tested, have unit tests and all of those kind of things. And we simply build upon them. And we allow basically cross-referencing things. So you can always reference from the IDL level Scala stuff and back, and even you can call also arbitrary Scala function in our schema. So you have basically like a directive which is called Scala resolver, which just gets the fully qualified name of a Scala function which needs to adhere to a certain interface, yes, but we would then automatically reflect it and hook into basically the resolver there. Again, like we did in here, we're already trying this out on another product effort. right? So what it means if people stop writing Scala, are we able to basically build a full product with that, and what kind of things are we running into it? What kind of things didn't we think about, and where do we have deltas between basically what the Scala implementation offers and what we have in IDL? We think it's more or less on par, but there might be some rough edges. And it looks fairly good so far. So the people who work with that like it. They really like the development flow it gives them. Right? Again, the improvement is quite drastic. And so far we haven't run or didn't run into sort of cases that really required a lot of people sitting together and figuring out how we are going to solve those kind of things there. Another thing that we're currently experimenting with is like, okay, how do we make sure that sort of the proxy in front and the underlying APIs are sort of fitting together. And what we are at least currently trying out is basically using snapshot tests, which are sort of always triggered when one of the teams contributes something there. This is basically written in Ruby, so it's fairly easy. In order to contribute to that, you don't have to do a lot of Ruby actually. You submit the query, you submit the variations of input values, and that would generate basically response files, snapshot files, and if there's a data like a normal snapshot test, you would be notified what to do about it. Either accept it, check it in, get the build green, or look into it whether it's really a problem. We haven't made a final verdict regarding this one yet, but it seems to work out okay-ish. In general, we don't have big problems so far with that. So, coming to the retro part. It was definitely good. GraphQL is awesome. So every front-end person that has worked at Xing with GraphQL was basically asking, okay, why haven't we done this always? Right? This is so obvious. Something like experimentation combined with documentation, trying out things. It sort of makes sense. It really works well for us. Equally, it's not even good. It's awesome. I mean, again, applause for Oleg. The Sangria is by far the best option you could have for running a GraphQL server, I believe. What also works really, really well for us is using this intermediate language for API design. Right, so everything is happening in GitHub, right, and in this IDL format already. And what the nice thing about that is actually, in order to get it sort of running, you just need to adorn it with directives, and then it's there. So it's just like the last 10 to 15%. As I said, it's easy to write by hand. Good syntax highlighting is there in basically every editor. It's already there in GitHub, also in the enterprise version there of GitHub. And our front-end people don't have any problems or didn't have any problems picking that up. It's easy to jump from that to the other thing I just showed you, right? So connected to the underlying APIs is a fairly low overhead in this process. Coming to the main thing, well, surprise, surprise, API design is still kind of hard. It's not really surprising, but it's just, you should be aware that GraphQL doesn't take away magically sort of the communication effort of designing a good API and agreeing on formats. Sometimes that is pretty involved. Especially at Xing, what takes us internally quite a long time is a switch basically from binary like request response to partial failures and carrying that into the front ends. There's on multiple levels actually, which is interesting. There's both on the front end side the perspective. Okay, does it make sense? It makes definitely harder for us, and there's also on the product level the discussion, okay, what is the user supposed to see if there are partial errors, right? But usually this is also what Facebook does it, and the way Facebook handles this kind of scenario. So what can fail is optional, and clients just need to deal with the messy world behind the scenes, right? Because things happen, and some parts might not be there, and that's for them a doable strategy, and we believe also for us a doable strategy. But it takes time to convince people for that. And if you just look at this magnificent pull request.
Does it stop someday?
Yes, it did.
So crazy.
In the end. So sometimes things are still a little bit evolved and needs a lot of communication even in that world. What's definitely also not so nice is, and it was especially true when we started the project, is when you're doing multi-platform development and the client libraries are just not there on an equal level. Unfortunately, which is a pity, because most of the GraphQL stuff was basically, or did originally come from the mobile context as Facebook. But what they ended up basically releasing is fully web-centered, at least the first iterations. This also, I believe, why the tooling as a first step is so web-focused, and iOS and Android were sort of an afterthought to that. You could literally feel that, and it was really like from, okay, there's an awesome implementation in JavaScript, there's an okay-ish implementation in iOS, and there's basically no implementation. Yes, there was a library, but in terms of features and in terms of what you could do with it, it was basically non-existent. This is better now, right? But this also gave us a constant deal of discussions internally, right? So for those people who would just basically do plain REST request and swap it out to GraphQL and need to adapt around pure GraphQL, is a completely different story than basically having a library in between that does heavy lifting for you, like usually the JavaScript side and the iOS side, for instance, stuff like that. Again, nowadays I think it's better because they sort of revamped their approach there, but at that time when we were starting, it was definitely not the best place to be in. Next one is namespacing. This is basically how our schema looks like, because GraphQL doesn't support, it's a type system without namespaces. What a pity. Facebook basically does exactly the same thing what you're seeing here internally with tools. So basically they have something that generates basically out of their service definitions the final schema and prefixes everything along the way. So they say for them it's not really a big issue, but they can kind of see where this might be sort of a scalability challenge. For those of us who don't have tools to automatically generate those kind of prefixes, we're currently having to resort to those kind of checks. And built-in checks during the build time, obviously, and schema build time. I talked to the people from Facebook at the GraphQL conference, and they were like, yeah, it's technically is not a big thing to implement, and if we hear from enough people, we can do it. But nobody has cried for it so far, but I definitely see it becoming an interesting question for us once the whole thing is getting larger and larger, right? Because there will be naming conflicts in one way or another. The other thing, which is also meh, which we would like to have, and which we currently emulate, is sort of tag-like information, which is available in Sangria. Sangria is sort of field tags, but it's not basically part of the GraphQL specification and the type system that is exported through the server. For instance, one of the things we would like to show in GraphQL is, okay, is this backed by a REST API? Is this basically, how complex is it? or how expensive is it? Who owns it? Those kind of things, right? Like everything that helps you making this whole thing work in a large environment where the schema is literally huge. We emulate it basically by a little bit of glue code that basically turns some field tags into documentation in this sort of format on which you're showing there with the hashbang. That is the map. And now we come to the error, the ugly part, and well, Freudian, which is error handling. And here I have to be very precise about it. It's not basically the nature of what it's doing, but it's how it sort of exposes it. I think the format is sort of difficult to handle without tools. And I think we're not the only one who experiencing this. Talking to the GraphQL guys on the conference, at least indicated that they've heard that several times now. So you have to be aware, for instance, that this kind of stuff we add with the documentation, with the ID and details part, this is all non-standard. This is usually not there. And the only thing you have there is basically a path which sort of maps into the query, right? So you have basically a pointer into the query where something goes wrong. But this is actually quite hard to program against generically. At least our front-enders didn't have a very good time with that. On top of that, basically, I mean, this is sort of the execution level side of that. But what happens if you don't even execute a query? How does the format looks like? Then it's completely undefined. And what we did in that case is basically we simply surface it exactly like that, also for authorization errors and parsing errors, analysis errors, to have a sort of a standardized format. And we documented it a lot. We gave them sort of text so that you can at least sort of, if you want to program against them, select by tags somehow, right? Which is more than just trying to read out the path and see where it maps to your query. And we're also using error codes, right? So when we basically block requests, when we don't execute requests because of throttling request errors because something was not properly parsed or had a semantic error, whatever, we indicate that also via status code. Obviously, the proxy adds another layer of complexity when we think about in terms of timeouts, right, and partial errors. Interestingly, I was today at AutoScout. They are also using Sangria, and they think it's perfectly the error handling. We had quite a bit of discussions regarding that. But all the experiences we had in discussions with our front-end people signal basically that it's not easy to grasp, that it's hard to wrap around, especially if you're coming from a binary world. Okay, I do a request, it either fails or not, and then if it's successful, I just take everything in there for granted. And now you switch it basically to something you get a successful request or you don't. And if you get a successful request, it might still not be 100% successful. There might be partial errors in there, and you have to figure out which portions basically were successful and adapt basically your product around that. Technically, I'm convinced that's absolutely the right strategy to do it. Absolutely. But I'm just not sure about the current where this is exposed, because it's definitely hard for front-end people. And where it's becoming also different, which is also not part of the GraphQL specification, is mutations. Like sometimes you want to basically expose business level errors in GraphQL, right? So And we started basically exposing them in that kind of error array. So you end up on the client side with a bunch of errors. Some of them might be sort of technical, something couldn't be resolved because of timeouts, and somewhere in there you have this business level exception. Obviously, nobody liked that. And what we ended up doing, which turned out then also afterwards like a more or less recommended way to do things, but we weren't clear about that, is basically to have domain level errors sort of as dedicated types in the selection set of mutations. So basically that you can, for a mutation, you can say, okay, give me back the error and resolve me that, and we insert some exclusive OR logic in between. So basically everything there is optional, and when you get basically an error there, everything is guaranteed. Everything else is guaranteed to be nil, right? If you don't get an error, we continue with the execution, which turned out to be much easier to handle for our client developers working with mutations, because it was just basically like doing the request, figuring out whether it was successful and whether there was no error object in there, and then they assumed sort of that everything's worked out. And this is how we approach it right now. So the domain level errors are modeled directly in the schema, and we use this error array as technical errors. Right, so semantic errors, throttling, those kind of things, those are in there, but those domain errors also might include something like back-end validations, right? This stuff you can't do basically on the front end, which you want to expose. They might include localized content somehow. It's also something we do where we forward basically the exact language header on the device basically to the underlying API. And it just then returns translated content if we ask for it. That's the nice thing for GraphQL, that we can selectively ask for that kind of localized error and just don't request it when we need it. And that turned out to be much, much easier to work with again from our front-end people. So as a summary, all in all, we're super happy with GraphQL so far. But as you might see from the whole process, we invested quite a lot in this whole thing, in building up the infrastructure and making sure that everything performs towards our expectation. Sangria, again, we think is the best choice. We're backing big on IDL, and time will tell whether that is the right decision or not. Right? Ask us in a year. Whether that was the sanest choice. Right now, all indicators point toward that. But after running that in production for more than a year, we have the hard facts. And let's talk again then. And as I said, some spots in GraphQL need to be improved. Right? There are some main areas, and I definitely think errors can be dealt with somewhat simpler. They know that. There's already discussion in the community, and I think at some point something will happen. Not sure how it will look like, but I think it's one of the areas where GraphQL definitely can be improved. And that's it.
Should we do some questions now, or should we save them for the QA?
Well, I mean, since I'm the only one in QA, I guess we can also do it now. I mean, shoot. Let's